Hi guys, I thought I'd put together a little video that I could put on YouTube so you guys could see it at your leisure about what we kind of discussed about facade, hands-on student facades. And this is really specifically to what work I've done with rigidized metals in Boston Valley terracotta. So the first image here is the mock-up. It's a 4x8 sheet of plywood turned horizontally. The whole scale of this was based on getting it all to fit on that one sheet of plywood. So the vertical track is proprietary to BVTC, Boston Valley Terracotta. You got a kind of a mullion gasketing between them. But the most important part of this installation or understanding the concept is this attachment by a clip system. So the clip both supports the weight of the tile below it, and then the next clip on the top holds the top panel and then is ready to accept the load of the panel above it. And they're slotted in a way that you can actually pick them up and push them down to make the attachment. So it's something that you can do repeatedly over and over. You can take the panels off, put them back on again without it doing any really kind of damage. You're not running new screws or anything in to fasten these systems in. So they do lend themselves to that kind of Legos kind of playing around with elements. It's important to note what's missing here. This is not a complete rain screen system. These channels should be fastened on a Z-girt, which gives it a standoff away from the plywood, which would be the facade. The plywood would be covered with a moisture barrier or like a blue skin, and then have a mineral wool insulation above that in order to make a complete rain screen system. That could happen on this very easily. And the intention here in this one was just, it's really an appearance mock-up. It's not not meant to be an instructional type of mock-up system. This is what the system looks like before the plywood was placed on it. And I'm showing you this to give you a little bit of clarity about this idea that it pivots. So we have a cylindrical, like a shaft, so you can actually just rotate the facade around. And that was very important in order to be able to simulate different times of day or different kinds of lighting effects on the facade. So we could kind of fake the time of day, so to speak, by the way we oriented the facade. And once again, these were all based on the idea of just doing appearance type evaluations. So here we have now the idea of integrating that terracotta with rigid, was Boston Valley's contribution with rigidized metals, textured metals. And it's just an experiment with the first experiment with making metal panels that we could substitute in for the terracotta, and then trying it with different kinds of textures. And next, after we went from this kind of flat planar experimentation, I had the fab shop produce us a couple of other tiles that had some depth to them and some other textures. And angles to them, just to experiment. In this case, by angling that, we could catch the skylight. So these, in a metal system, this would actually be catching the blue sky and have a much different appearance at, from the viewer at grade level. Not very effective today, obviously, because this was done on an overcast sky. This panel up here is kind of interesting or unique in that it's a curved form panel. The idea, we have a laser available to us, so all of the cutting out of the metal is done on a laser. And in order to create this curved effect, I perforated the metal. That allowed me to then hand fold it in order to create this kind of a three-dimensionality of the curved form to it. So I really had a wonderful chance to play with all kinds of different techniques. This is another shot kind of exploring that idea of depth. And moving out of that flat plane, and something that they're thinking about when we think about what students could do to amend or add to a facade if it was built like this. This gives you an idea of the structural, just the basic dimensions of the system. Once again, a 4x8 sheet. The panels were all based at width on how I could fit those tracks onto a sheet. So all the scaling was based on really a lot of fabrication convenience. That ended up with the panels being 1'10", which is really quite small. I believe they're 8-inch high panels. One of the good things about that, though, is because they are small, they can be handled by just about anyone. So weight doesn't become a factor for somebody who might have difficulty manipulating heavy objects, like a student. So here's just another kind of frame detail. This was produced for Boston Valley while I was working for Rigidized Metals, because they'd requested their own mock-up, but they were kind of intrigued by the idea and wanted to produce their own. So I came up with some drawings for them to be able to do that. This is the kind of the interior view, or the kind of description about how that metal panel attaches to a system that was designed for terracotta. So on the left here, you can see there's a tab that's bent in that is catching that clip on the panel system. Note that it's perforated here. Again, this was hand bent over. This plastic on here is just a protective film on the stainless, and I was just too lazy to remove it before I took the picture. But it had to be perforated, and it had to be hand bent, or it had to be hand bent, and perforating was the easy way to do that, because there was no way to fabricate that. You couldn't get the break forming tool to make that final bend, because there'd be nowhere for the tool to get into this opening. And then over here you can see what the top could be conventionally formed, very much like the original terracotta. And even in the whole function of the panel, it still functions as a rain screen system, with its ability to one panel to overlap the next one and basically shed water from one panel over the next. And this is just a section detail kind of outlining that idea about how it was fabricated to be attached and matched with the terracotta. A technical drawing for fabrication, or the start of a technical drawing on how we would cut that panel out. And then I wanted to finish up saying that there's the hands-on physical working through that system, but there's also I've developed for advanced structural concepts this idea of a very detailed Revit model. So in this case, we have a curtain wall system, and the infill panels are actually a full terracotta system. What I mean by full is there's the panel, there's the clips, the attachment systems, the insulation, the plywood, even the drywall on the other side of the wall. And then the assignment was given to the students. They were able to use the preformed Revit family element, place it into a building, modify tile systems, and then actually one unit would carry 3 different shapes with it, or 4 different, or unlimited basically. So they could actually just make visible certain ones to create different kinds of pattern systems. And then they could hide components in order to create these kind of descriptive views about how this system works. One of the goals of the course here, or of this module or the project, was to show this kind of need for depth in order to accommodate the window and glazing systems. So they got a chance to experiment with adding window systems to that. And then as that played out in the studio project, these are some of the examples of student work. So this is, in advanced structural concepts, this is something they should have learned a long time ago. So I really would suggest we can easily pull this out of advanced structural concepts and introduce it into construction tech 1 or 2, and maybe run some way related to what might be happening in design fundamentals. So maybe one semester they're building a real rain screen, and then the next one they could be working on modeling a rain screen system. Let me just step back once before I finish and talk about how do students make their own panel systems to go along with this. And I could easily see that what we would do is make a metal frame that was hollowed out and set shallower that students could actually make mock-up faces to. This is just one idea, and attach to them. So they could make unique cast concrete that could simulate terracotta or any other kind of patterning systems on these what would be reusable panels. And I don't know if I mentioned this at the beginning, but this system lends itself to being reusable. Because of the way the clip systems work, there's no screws, so it's easy for somebody to remove all these panels in a few minutes and reattach them with a different style. So there's from year to year reusability of this kind of a system for students to get that kind of tactile hands-on experience with a real-world material. So I hope this is helpful and stimulates some conversations we can have. And if you want to move forward with some of the things that are related to Boston Valley, I can put us in contact with that. So look forward to some more discussion.